Alright, before moving forward, please do not forget to check video description. You will find the link of this blog and the link to download full source code. If you haven't watched first part of the video, you will also find the link there. Please watch it. And please do not forget to subscribe my channel to support me. Okay, now let's discuss second part, data structure, collision detection and scoring techniques. And also we will discuss source code of the game in details. In this game, there are three major objects. The first one is a small box, which is called Mino, and combination of Mino is Tetrimino, which is a shape. And we will arrange the shapes on Tetris board, right? So that is another object. So within the board, there are small boxes, right? So that small box is represented as an object. So let me show you the picture to explain it clearly. So here this one has is a minnow. It is actually nothing but just a xy coordinate. So this one minnow is represented by xy coordinate where we print the hash character, and combination of four coordinate is a shapes, right? And shapes is arranged within this Tetris board. So when we arrange this Tetris board, each individual boxes are filled within the board because this whole Tetris board is also represented by xy coordinate, right? The size of the board is 11 toward x-axis and 21 toward y-axis. So within the Tetris board there are 231 boxes. So each boxes is also an object, right? So to represent these three boxes, I have created three structure variable. The first one is point2D, which will hold the xy coordinate, and it is also represent Mino, that one small little box. And another structure is Tetrimino, which is a combination of four coordinates. So four point2D type array, which is a body here. And this structure represent the shapes. And this little Tetris box, this will represent the each individual boxes within the Tetris board, right? And each box is also a 2D coordinate, xy coordinate, and another parameter is there, which is a flag. So flag means that box is filled by shapes or not. So when user will arrange the shapes on the board, on the Tetris board, if that board or the part of the board is filled, then this flag variable will be 1, right? And this will help us to calculate the scoring also. So let's explain it differently. Let's say within a box there are 231 boxes, right? And initially coordinate of all those boxes is already calculated, but the flag will be 0. So it means we will not display hash at that box, so at that location. If user will fill that box using a shape, then it means the flag will be 1. Then it means we will display hash character at that coordinate, at that box. So that's the logic. And another variable is window to represent four corner of the window. So here we have four corners. So this will help us to draw the window. And Tetrimino variable, array variable, it will represent all 7 shapes. And the current key is a current shapes. And next t is a variable which represent the next Tetrimino, which will come later. And here the Tetris box, so this will represent whole Tetris board. All total there are 231 boxes within Tetris board, right? And I have created two-dimensional array for Tetris box because to represent row and column. And the first index is number of row, which is a y coordinate, so which is a 21, and second index is x coordinate, which represent the column. And there are other variables which represent vector of the game. The first one represent translation vector, core translate back. So this is current translation vector, which is 0, 11. It's toward a y-axis. And another vector is unit vector, which is represented by unique back array, and it has 4 values which represent all 4 direction. First one is positive x-axis, first one is positive y-axis, and second one is negative y-axis, which is downward, and third one is positive x-axis, which is left, and last one is negative x-axis, which is right. And another vector is called rotation back, so it is a rotation vector, and first element is vector to rotate clockwise, and second element is vector to rotate anti-clockwise, and we already discussed about it in first part how we got these values. And unit vec dir is the index to get the unit vector, and initial value is 1, which is 0 minus 1, and it means the initial direction of the Tetrimino will be downward toward negative y-axis. And score variable is to store score. Now let's discuss collision detection techniques. First rule is when shapes, so let me bring this picture here. So when these shapes move at the bottom of the window, then it means it collided, and we will add that shapes on the board. And when this shapes is moving and collided with the boxes which is already there on the board, then that is also a collision, and we will add that shapes on the board. And also that shapes must move downward, not sidewise. If shapes is moving along x-axis, either left or right, and it collided with existing box on the board, then we will not stop there, but we will not move forward. I mean, we will not move toward x-axis. We will stop there, and we will continue until this shapes reach at the bottom or it collided with existing box. And another rule is when this shapes is moved toward left or right, and if it reaches at the border of the window, then we will stop there. We will not move it forward and take it outside of the window. So we will not do that. We will stop there, and it will continue toward downward. And the last rule is when this Tetris shape is collided with the box and whole 4 shapes are outside of the window at the top, then it means game is over. So these are the overall collision techniques. Now let's discuss the method to calculate score. When user will arrange the shapes on the board and whole row is completed, it means user win the points, and that row is deleted and all the boxes from the top is shifted toward downward, right? So that's the overall concept that we have to achieve. And to achieve that, we will multiply the flag of each boxes row wise. As you know, when we add the shapes on the board, we will change the value of flag to 1. So that's our concept. So if we multiply the value of flag row wise and the product is 1, it means that row is completed. And if any of the boxes is empty, it means the flag value is 0, then the overall product will be 0. So that means that row is not completed. So that's the simple logic that I have implemented here. And whenever we find the product 1, then we will increment the score by 10, and we will delete that row and we will shift whole boxes downward. So that's the overall scoring technique. All right, we have discussed all theoretical concept of the game. Now I will discuss the source code of the game in details. Source code is not that big. Here we have 193, and here we have around 484 lines of code, and here only 10. So there are all total 680 lines of source code. So it's small and it's not that complex. It's very easy to understand, and I will do my best to explain it in details. As you know, we already discussed goToXY function in our previous video, so we will not discuss it here. Let's move to Tetris header file. First 7 macro definition represents 7 Tetrimino, let's say 7 shapes, and we use these macro as an index of an array to get corresponding Tetrimino. Numbox represent total number of boxes within each Tetrimino. Win half x and win half y represent half size of an window toward x-axis and y-axis, and it will include a border as well. And we use these values to calculate coordinate of 4 corner of an window to display the window. These 4 macro definition represent the total number of units available on x-axis and y-axis, And these values also define the size of the Tetris board where user can play, and it will also limit the number of move user can do. And using these values we also calculate total number of points, total number of coordinates within Tetris board, and also we'll use this value for collision detection. And last two macro definition define the total number of units available within y-axis and x-axis. And toward y-axis there is 21 including center, and toward x-axis there is 11 unit including center. And we already discussed these data structure, point to the Tetriminos and all these earlier, so let's skip these parts. Now let's discuss initialize shapes function. We already discussed about these data structure earlier, so let's move to initialize shapes function. At first we calculate coordinate of all four corners of the window and initialize window variable, and using this value we will display window. And after that we initialize all 7 Tetrimino shapes using fixed coordinate, and all Tetrimino shapes are created at the center. You can check the coordinate, all shapes has center coordinate within it. And at last we initialize Tetris board array variable by the coordinate of within Tetris board. We calculate all possible coordinate within the Tetris board and assign it to a box element of this array variable. And also we will initialize flag variable by 0. So flag variable 0 means that box is empty. Yeah, all good about initialize shapes function, and this function is called at the very beginning of the game. Update translate vector function update the current translation vector based on the unit vector. Here the unit vector is direction of the shapes, and by default the direction of the shape is toward downward, that is toward a negative y-axis. So each frame of the game we will decrease y-axis by 1 unit, and if user press left or right then we will increase or decrease x coordinate of current translation vector based on the user input. And you will understand about this function later, we will discuss in details. And revert translation vector function will revert the current translation vector to previous state based on the unit direction or based on the direction of the shapes, and we will discuss about it. And there are many scenarios we need this function, and it is very important function. And reset translation vector, so when shapes will move all the way to a downward or it will collide with boxes within the board, then next shapes or next Tetrimino will start from the beginning, right? So at that time we have to reset translation vector, so this is the function for that purpose. And set current next Tetrimino function, so this function will calculate will find the current Tetrimino and next Tetrimino by using the random value passed in its parameter. And this function is called at the very first beginning because at first there is no shapes, there is no next shapes or there is no current shapes, so it will initialize both current and next shapes by using random value passed in its parameter. And next Tetrimino shapes will assign current Tetrimino by next Tetrimino, and next Tetrimino is calculated by using the random value passed on its parameter. And check collision with boxes function will check the collision of the shapes with the boxes which are already inside the Tetris board. So here we will check each box by at a time. So let's say in a Tetrimino there are 4 boxes, so we will run check collision boxes 4 times. So technically we are scanning whole Tetris board and checking collision with each boxes of the Tetris. So we will discuss about this later. And check out of board function, so this check out of board function will find whether Tetris is moving out of the window sidewise toward a native toward x-axis. So when user will press left or right direction, let's say user press right direction many times, then it cannot go always in a right direction. So there is a limit, it cannot go outside of the window, so that is checked by using this function. Let's discuss translate Tetrimino function. This function is very important. If you understand this function, then you will understand whole game. The basic rule to translate shapes is very easy. At first we have to check rotation flag. If there is rotation, then we will rotate shape first and then we will translate it. But before rotating it and before translating it, we have to consider many scenarios. Let me open picture and let's discuss about those scenarios. Let's take this as an example. Line is at the side of the window, and here in this position we must not rotate this line, because if we rotate it will move out of the window. So in that scenario we have to stop. And second scenario is we must not move this line left side also. If we move, then it will go out of the window, so that scenario also we have to check. And third scenario is, let's say user want to move this line right side and it collided with another line here vertically, so it collided from the side. So in that scenario we must not move that line right side. We have to stop there and move line downward. Okay, so that's the another scenario. And the fourth scenario is, let's say line is moving downward and it collided with box vertically from the top, then that is a end of move scenario. And at that scenario we have to stop, we have to add that shapes on the board and we have to start next Tetrimino. Another scenario is, let's say Tetrimino started from the top and collided with the box, and any of the box within Tetrimino is unable to enter the game window, let's say Tetris board, then that is end of move scenario. Also that is a game over scenario, so that also we have to consider. And our last scenario is that happens very at the beginning. So let's say boxes are not here on the board, its board is empty, and shapes move all the way toward bottom of the board, then that is end of move scenario. But that is not the end of game scenario. So in that scenario we simply add the shapes on the board and next Tetrimino will start. Let's implement all this scenario in the source code. At first we will rotate and translate shapes and save it into temporary variable and check all the condition, and if all the condition pass, then only we finally rotate and translate it. So that's the reason we created these two temporary variable here. And as we discussed, at first we will rotate, we will check the rotation flag here, and we will rotate the Tetrimino here and save it into rotation temporary variable. And this is the rotation formula which we already discussed in our previous video. And after rotating we will translate the shapes also, because as you know all the shapes are created at the center. So at the beginning we will rotate the shapes at the center and then translate it, and we will check whether that shapes went out of the board or not, and whether that shapes is collided with the box or not. So one more condition I forgot to discuss. So here let's say the shapes is at the bottom and user want to rotate it, and while rotating that shapes might collide with the existing boxes, right? So that situation also we have to consider. If that shapes will collide after rotation, then we must not rotate that. So that also we have to check, and that is done here. So at first we will check if any boxes are moving out of the window or not. Then we will set out of board flag 1, and again we will check the collision with the boxes. If there is no collision, let's say there is a collision, then we will set collision variable 1. And if there is no collision, if out of box is 0 and collision is 0, then finally we will rotate and we will assign that that value into Tetrimino. So we will rotate the shapes in our original source variable. So this is our original source variable from where we will get the Tetrimino data, right? So there we will rotate and save it. So at this stage we will not translate, just simply rotate only, and we will reset outer board and collision variable. And after rotation successfully, if there is rotation then we will rotate, if there is no rotation then nothing will happen. And after rotation we will translate the Tetrimino and save it into current temp variable, and side by side we will check whether it is moved out of box or not. If that shapes moved out of the box, then it means it was moving either left or right side, And in that scenario we will revert translation vector, and we will set unit vector downward, and we will update translation vector again. So in this scenario, now the translation vector will be downward, not left side or right side. And again we will translate the shapes. And after translating, we will check collision detection. And collision detection might be two types: one either vertically or horizontally, and that will decide by the direction of the shapes. So if shapes is moving downward, let's say unit direction is 1, then it is collided vertically. If direction is other than 1, either 2 or 3, then it collided horizontally. So that is indicated by stop y variable here. Let's say there is a collision and it collided left side, I mean it collided horizontally, then that is not a end of move scenario. That scenario is we have to stop moving it left side or right side. We have to move that shapes downward only. So that is done here. So if there is a collision and collided horizontally, then again we will revert translation vector, and we will set unit vector 1 and update the translation vector. So now the translation vector is toward downward, and we will reset the variable collision and stop y, and again we will translate it. So that's the logic. And after translation, again we will check collision detection, and if there is collision, then we will set collision y and stop y1, because here we already checked horizontal collision, so no need to check horizontal collision again, because it is obvious that the shapes is moving downward. So we will check overall collision here. Now in this section of the code, we check whether shapes move at the bottom or not. So that is done here. If any box coordinate of the shapes is equal to negative board half y, that is -10, then it means shapes reach at the bottom, and at that time we will mark stop y variable as a 2. And this section will check whether any box of the shapes is outside of the window. So it's like it's checking with positive board half y value, that is 10. So it means any of the box is outside of the window, and also it is collided vertically, right? So at the beginning, always all the shapes are outside of the window, right? So that also we have to consider. So if box is collided and any box of the Tetrimino is outside of the board, then that is end of the game scenario. So in that case, we will assign stop y variable as a 3. And finally there is no collision, then we will translate the shapes and assign it to current variables. And up to here we are doing at the I mean in a temporary variable, right? All the scenario passed, and finally we translated the shapes. Now let's discuss set Tetris board function. This function actually add the shapes on the board, and when end of move scenario happens, then we will compare the coordinate of the boxes of the board with coordinate of boxes of the shapes, and coordinate is same, then we will set flag with value 1. So it means the shapes is added on that box or on that board. And shift boxes top to bottom function will shift the value of top box to downward. So let's say the row is completed, then user will win the points, right? So at that time we have to delete that row and shift all the boxes downward. So to do that, we have to shift the value of array of Tetris board from top to bottom. So this is done using this function. And now this is draw window function. This function will draw the border of the window using a special hexadecimal character. So this is actually print square, a dotted square as shown here. So this is the one which is printed by using this special character. And draw Tetrimino. So this will draw the hash character to draw the Tetrimino. Remove Tetrimino function will remove the Tetrimino by printing space character on that location, and this will give us animation effect. Let me run the program and explain you. At first we will print the Tetrimino, and we will put program into sleep mode, and after keeping into sleep mode for 300 millisecond, we will delete that Tetrimino from that location, and we will print another Tetrimino in another location. We will translate and draw in another location. So this will give us animation effect here. So this is the logic to get the animation. And remove next Tetrimino is also same. When next Tetrimino is different, then we will remove it. And remove boxes in the row. So this happens when user will gain the point, when user will arrange all the boxes toward the row. When row is completed, then we have to delete whole row. So that is done using this function. Redraw whole boxes. So redraw boxes means we will redraw whole window again, and this is done when user will get the score. I mean, when user will complete the row, then user will get the score. At that time we have to delete that row and shift whole boxes right downward. So at that time we will call this function and we will redraw whole window. So this will give us like it is moving hold the boxes downward, but actually we redrawing everything. And this is the last function, and check row and redraw board function. So this function will help to check completed row and increase the score. And to check completed row, logic is very simple. We will find the product of flag t variable from for the whole row. If product is 1, then that row is completed. If product is 0, then row is not completed. The logic here is simple. And if product is 1, we will increase the score, and we will remove the boxes in that row, and we will shift the boxes from top to bottom, and we will redraw all boxes again. So this is the logic here in the case where row is completed. I hope you understood the concept of all the function written inside Tetris header file. So now let's move to main.C file. This macro definition is for keyboard input, and the first 4 is for the arrow keys, top, left, right and down, and this one is for escape key. And these 3 macro is for the speed of the game, and for the low we will sleep the game for 200 millisecond, and for medium 150 and high 125 millisecond. Hide cursor function will hide the mouse cursor, it will make game very clean. And this is the delay function to sleep the program by millisecond. And these are for all global variables. And inside main function we will simply start the gameplay function. Inside gameplay function, here we will calculate random value for the current and next Tetrimino, and we hide the cursor and we initialize shapes. Here we calculate the coordinate of the window and coordinate of all the shapes, and after calculating, after initializing, we draw the window and we reset translation vector, and this is for the calculating score. And then we set current and next Tetrimino. It will get the current shapes and next shapes by using a random value passed as a parameter. And then we simply start the game and we capture the status. If status is greater than 0, greater than 1, then game over. And again we will give user opportunity to start the game again. Here start game function is the main function. At first we draw next Tetrimino at the side of the window, and after drawing we simply start game infinite loop, and this loop will never break unless game finish. I mean, if there is a game over situation, then only this loop will break. And after that we will create another infinite loop, but this loop will break if user will press any key. And here we simply draw the score and label, and then we update translation vector. And after updating translation vector, we translate the shapes using translate Tetrimino function, and we capture the return parameter on end of move variable. And after translating, we simply draw the shapes current Tetrimino we will draw, and after drawing we will reset the unit vector. And if end of move is 0, it means there is no any obstacle, the shapes is moving. In that scenario, if score is less than 10, we will run the game in low speed. So it means we are putting the game on a sleep for just 200 millisecond. And if score is greater than equal to 10 and less than 25, then we will run game in medium speed. And if score is greater than and equal to 25, then we run the game in high speed. And after sleeping the game, we remove the Tetrimino. First we draw, we put the game on sleep, and we remove the Tetrimino. And again we draw Tetrimino here, right? So this will continue, and this way we get the nice animation effect. And let's say if there is a end of move scenario, end of move is 1 and 2. 1 and 2 means 1 means it collided with the box, 2 means shapes move at the bottom. In that scenario, we simply add the shapes on the board. So this is done by set Tetris board function, and we remove the next Tetrimino, which is displayed at the side of the board. And again we calculate random value for next Tetrimino, and then pass that value into get next Tetrimino function and get the next Tetrimino. And at this scenario, the current Tetrimino will be assigned by next Tetrimino, and next Tetrimino is calculated by random shapes. And reset translation vector, it will reset the translation vector back to beginning point, and draw next Tetrimino. So after getting next random next Tetrimino, we will draw again, and this will check the score. So this function will check whether row is completed or not. And the next is end of move 3 situation. This is game over situation. If end of move value is 3, game is over. We simply remove the end of move value from here, and this function will get break, and this function, I mean this loop will get exited, and this loop will also exit, and the game will go here. So value is returned to status flag, right? And let's see here. Let's say while running this loop, when this while loop is running and user press any key to move the shapes left or right, then this loop will break, and using this getCS function we capture the keyboard input. If keyboard input is top, rotation flag is 0. If keyboard input is down, rotation flag is 1. So this one is clockwise and this one is anti-clockwise. Keyboard input is left, means unit direction is 3, and if keyboard input is right, unit direction is 2. So this is the logic to move the shapes left, right, and rotate clockwise and anti-clockwise. And at last, if keyboard input is escape key, then we will exit the game, and we will return the game status here. Yeah, that's all, and this is the end of the game. I hope you understood the concept. If you have any question, please leave the comment, and please do not forget to subscribe my channel to support me. Thank you. See you in the next video. Bye bye.